Hello everyone, this is Ritu Shreyas. My seminar topic is arrays 1D and 2D. I would like to explain about arrays. Okay, so what are arrays? So arrays are a way to store multiple values of the same type in a single variable. You can store a number of different values of the same type, same data type, that may be integer, float, or all the characters, etc., in a single variable. It is something like a matchbox holding all the matches sticks inside the same matchbox. Okay, inside the same box. So array is like a row of box which where each box holds one value, and all these values must be of the same data type, as I said, that may be integers or all the characters. So what is the use of arrays? Means it is used to organize the data, and it can make easier to access and manage the data that we have stored. Example for arrays. In case if you want to store the marks of 5 students, then you are going to write the particular statement, that is int marks of 5. Okay, int marks of 5, the marks that is of the user choice, whatever the marks that is scored by the student is given. Like the example that we have taken is 85, 90, 78, 92, 88, etc. So the indexing starts with 0. So 85 will have the index 0, and the last index goes with n minus 1. So we have 5 int marks of 5. We are storing the marks of 5 students. Means the first index will be 0 and the last index is n minus 1, that is 5 minus 1 is 4. So here marks is the name of the array, okay, which is depends on the user, whatever the user needs. If we are storing the marks, you can write it as marks. If we're storing the data, you can write data, etc. You can give the name as per the user choice. And it stores 5 integer values, because if you can see here, the data type is int. So it stores 5 integers value, and you can access each marks. You can access each marks by giving the index, that is marks of 0, marks of 1, etc. But always ensure that the index is given within the square brackets. Okay. The next thing is, why do we use arrays? Okay. So we use arrays to avoid creating many separate variables. So in a lengthy program, if you have many variables, it leads to confusion. So by using arrays, you can store a number of data in a same variable of the same data type. So you can avoid many separate variables. And the second use of arrays is to easily loop through and manage groups of related data. So these are the uses of arrays. Next one is, we got to know what are the uses. Next one is application of arrays. What are the application of arrays? Firstly, data storage. Data storage store multiple values like grades, names, temperature. So as in the previous example, we stored the marks of 5 students of the data type int. Okay, so that was an example for data storage. Okay, that was a grades or scores. So grades is nothing but you can there be scoring like A grade, B grade. That is, they'll use a character data type. Names, they'll use a string data type. Temperature, they're going to use float, because there will be a point different values. So they'll use float or double data type. The next application of arrays, loop operations. So loop operations, where we are going to use a for loop and all. What are the looping operations we have? And where are they really using the loop operation is, they are going to perform tasks like average, maximum, minimum, search, etc. So search techniques and all, like the linear search, binary search, where you're going to assign the values that may be temporary, the current value or anything. You're going to use the index of that particular array. Okay, array, the index of that particular array, and then you are going to store the values that are there, that may be current, that may be temporary, etc. So basically the loop operations are easily perform tasks like average, max, min and search. Search, that is linear and binary search. And the basis for data structure, so what we are studying in the current one, that is the used in stack, used in queue matrices. We saw the lab programs that were there based on stacks, queues, etc. So we are using it in data structures also. Next one is image processing. Image processing. So when we look at any image for that matter, so each image is made up of some pixels. Okay, so those pixels that are there, you can see the pixels of that image. If you look into that image, information or the details of that image, you can see that there will be numbers. Okay, 3 to 4 digit numbers cross another 3 to 4 digit numbers. So 2D arrays are being used to store that pixel data in the arrays. Okay, next another use or the application of arrays is algorithms. Okay, algorithms, it is useful in sorting and searching technique. Bubble sort technique that we have seen, searching techniques like linear search, binary search, etc. Those are the algorithms. Okay, next one is database tables. Okay, database tables. So where database means nothing but they're going to store the data. Okay, they're going to store the data that is going to represent what? Rows and columns. So the rows, they're going to represent rows and columns. And the next application is simulation. Simulation, model real world systems. Example, weather, traffic, etc. So weather, they're going to be measured in a Fahrenheit or the Celsius, right? So degrees are being measured. So degrees, in that they'll have data. Okay, so like 37 degree, okay, etc. 37, 38, 32 degrees Celsius, whatever it may be. So they're going to store that data. Okay, they're going to store that data using the arrays. And we are also using it in the gaming world. A gaming world, like manage the game states, player data and board. So most of the applications that we see in our real world are using arrays. So why do we use arrays? Mean it is going to organize and process similar data efficiently. What do you mean by similar data? So we're going to store a number of values under the same variable of the same data type. That is array. Okay, the next we are going to see what are the types of array. So the types of array are 1D array, that is one dimensional array. Next, one dimensional array, two dimensional array, multi-dimensional array, dynamic array, jagged array. So what is a 1D array? So 1D array is a simple list. So 1D array is a simple list. Example, numbers in a line. Okay, we are going to represent only numbers in a line. Example, that is a one dimensional array. Okay, one dimensional array. Where a two dimensional array, you are going to represent rows and columns, a table like structure. Multi-dimensional array is array with 3 or more dimensions. Dynamic array is a size can change at runtime. Example, Python lists, Java lists, etc. Jagged array, array of arrays with different lengths. Example, in Java. So we are limiting our topic just to 1D array, 2D array, 2D array. Okay, so now let us see what is a one-dimensional array. So a one-dimensional array is a simple list of elements of the same data type stored in a single row. Okay, so just get to know that it is a simple list of elements which is having same data type and it is stored in a single row. And it stores data in a linear form. So in data structure, you can store data in a linear form also, a non-linear form also. So arrays, stacks and queue, you can store the data in the linear form. So 1D array is such where data is stored in the linear form. So how can you access the elements in the array? So there will be a number of elements of the same data type stored in a single variable. Okay, that is nothing but array and also a 1D array. So you can access the elements using a single index as I told. So if there are 5 elements, index starts with 0 and the last index ends with n minus 1 where n is 5. So 5 minus 1 is 4. Okay, so all the elements are accessed using a single index and the elements are stored in contiguous memory location. Contiguous memory location. Contiguous memory location means continuous memory location. So in case you take an example, okay, in case you take an example here, we have taken an example. So where index starts with 0, as I said, 0. Okay, there are 5 elements here if you can see, that is 10. Look at the values and the index properly. So the index is 0, 1, 2, 3 and 4. Means there are 5 elements where the starting index is 0. Starting index is 0 and the ending index is n minus 1, that is 5 minus 1, that is 4. So the what is a value that we are storing here? 10, 20, 30, 40 and 50. So they said, so in the previous slide if you can see, the elements are stored in contiguous memory location, continuous memory location. So what the ending line that I have mentioned here, it is the memory location. So let's say this is an integer. So integer is going to store 2 bytes. So it starts with 1000. Starting is 1000. The next index is the memory is 1002, which is index number 1, which is storing 20. In the same way, 1004 is storing 30, index number 2. 1006, 40, 3. 1008, 50, 4. So you can see that there are difference of 2 bits because integer stores 2 bytes. Okay, this was the example. Okay. Now, the basic operations on arrays. The basic operations on array, the first one is traversal. So what do you mean by traversal? Traversal means it is similar to the word travel. Means you are going to visit a place. In the same way, traversal means you are going to visit each element of the array. Okay. So you are going to visit each element of the array. And how is it done? Okay. How is it done usually? You are going to use a loop. Okay, the example we have taken here is for int I is equal to 0 because index starts with 0. I is less than the size. So size you take it as 5. Okay, if you take the size as 5, I should be less than the size means the last number that you can take will be I holds values of 0, 1, 2, 3 and 4. That is nothing but n minus 1 values I will be storing. Then incrementing, we are incrementing with I plus plus. Okay, I plus plus, which is a post increment. First the value is incremented, you are going to take that value. Okay. So that is a prefix increment. Prefix. So whatever it is being plus plus I is a prefix. I plus plus is a post increment. So then within the braces of the for loop, we have printf percentage %d. So as we are using an integer data types, it is percentage %d and array of I. Okay, array of I. Array, we are going to print the values of 0th index, first index, second index, third index and fourth index. So if you look at the example that we have taken previously, so array index starts with 0, array index ends with 0, ends with 4. So it will print the values from 0 to 4 like 10, 20, 30, 40, 50. Okay. So traversal, you get to know by the name itself, visiting each element of the array. Okay, that was one of the operation of array. The second operation is insertion. Okay, the second operation is insertion. Okay, insertion. Insertion means adding a new element at a specific position in static arrays. This may require shifting elements. Okay, insertion means adding a new element at a specific position. In static arrays, this may require shifting elements. Static arrays where it does not change during the runtime. Dynamic array, it is going to change during the runtime. So here we have taken an example, that is insert 50 at position number 2. So the code that we have taken is for int I is equal to size, I is greater than the position, I minus minus, array of I is equal to array of I minus 1. Okay, firstly, we are making up a space and then we are going to add a new element. Okay, so array of the position, the particular position, that is array position number 2. At the position number 2, I am going to insert 50 and then I am going to increment the size by 1. Okay, that is about insertion. Okay, the next one is deletion. Deletion is nothing but removing an element from the specific position, which involves shifting. Okay, why do you need to shift? For insertion or deletion, why do you need to shift? Because you are making up a space for that particular element. So for insertion means you are going to move the element from the particular position where you want to store. So insertion here. So here insert 50 at position 2. Okay, insert 50 at position number 2 means at position number 2 there will be another value. I need to push that value to another next index and then I need to store 50 over there. Okay, deletion means this also involves shifting. So delete element at position number 2 and the code for this here, it is given as for int I is equal to position I is less than size minus 1 I plus plus. Array of I is equal to array of I plus 1. This is a code within the for loop and outside the for loop we have size minus minus. So this code deletes an element at position number 2. Okay, next, searching. So searching, what do you mean by searching? You're going to find the location of a specific value, whether a particular element is present or not. You're going to search. Okay, you can use linear search or binary search. Linear and binary search. Binary search if the data is sorted. Okay, unsorted, linear search. Sorted, binary search. And the code that we have here is for int I is equal to 0, I is less than size, I plus plus. If array of I is equal to key, then the particular value is found at the particular index. Okay, array of I means, so say our I values will be from 0, 1, 2, 3, 4. So array of that index, I'll have some value, right? If it is equal to key is having the value that I'm going to search for. Okay, if it is there, then search, linear search done or binary search done. That is a searching. Okay, the next one is updating. So what do you mean by updating? Updating means changing the value of an existing value. Update means I'm going to update the value of the existing element. So I can just use a simple statement like array of 2 is equal to 75. Means updates the third element to 75. Array of 2 means, why they are telling us it updates the third element to 75? Because array index starts with 0. So array of 2 means they're referring to the third element. Okay, so it is referring to the third element. Okay, so it will have different values. So by using this simple statement here, array of 2 is equal to 75, I am going to update the third element to 75. Okay, the next topic we have in our list is two-dimensional array. Okay, that is nothing but 2D array. So the first we discussed was all about 1D array. What is a 1D array? What is the use of 1D array? Applications of 1D array? What are the operations that can be performed using a 1D array, etc. Now we are going to learn about the two-dimensional array or a 2D array. So when we were learning the types of array, 2D array was one of it. So where you saw a word that is table, means 2D array is an array of arrays like a table with rows and columns. Okay, so what is the difference between 1 and 2D array means? 1D array, linear form you are going to store it. Okay, just a single row you will be having. Whereas 2D array is with rows and columns. So data is arranged in rows and columns. Okay, data is arranged in rows and columns. Accessed using two index. Okay, that is one for row, one for column. What is it used for? It is used for representing matrix. So matrix will be having rows and columns, right? So m cross n. So we are using it for representing matrices, 2D array. We are using for grids, we are using for tables, etc. So what is a syntax? Syntax example that is listed here. So int matrix. Matrix square brackets, in the square brackets we have 2 and 3. Okay, so what does it represent? The first one represents the row, the second one represents the column. So 2 rows and 3 columns, but the index starts with 0, 1, 2 like that, and 3 columns we have. Okay, inside that I have the elements they have given it is. So this is for one row. They have given here. Okay, 1, 2, 3. Next 4, 5, 6. And the starting braces have been closed with a semicolon. How are you getting to know which element are they referring to? So here we've taken, so matrix. So here you can see it is stored in the form of a table. If you can see a table that is rows and columns, okay, that is a 2D array. Okay, so this is for the I have 1, 2, 3. 3 column and 1, 2. 2 rows. Okay. So here matrix 0. Matrix 0, 0. That is 0 index and 0 index, row and column. That is referring to 1. In the same way 0, 1 refers to 2. 0, 2 refers to 3. 1 and 0. So you can see here 1 and 0 refers to 4. 1 and 1 refers to 5. 1 and 2 refers to 6. This is about two-dimensional array. So what are the uses of two-dimensional array? It is used for storing matrices in mathematics. Okay, because there will be rows and columns, m cross n. So we are going to use for storing matrices representing game boards like chess or tic-tac-toe. Tables and spreadsheets. So wherever rows and columns comes into picture, we'll use a 2D array. Image pixel data in grayscale. Okay, image pixel data in grayscale. So an image is made up of pixel as we discussed earlier. So that wherever you see rows and columns, we are going to use a 2D array. So 2D array helps to organize data in a grid format, making them ideal for many real world applications. Okay. Next, how do you access the elements in a two-dimensional array? So we have a short code that is given here. For int I is equal to 0, I is less than 2, I plus plus. For int j is equal to 0, j is less than 3, j plus plus. Printf percentage d, matrix I of j. Printf slash n. Okay, so the previous example that we took with 1, 2, 3, 4, 5, 6. So we're just replacing it with 10, 20, 30, 40, 50 and 60. So this above code here, it is going to print 10, 20, 30, 40, 50, 60. If I want to know the particular element, so 10 means at index 0, 0, 20, 0, 1, 30, index 0, 2, 40, 1, 0, 50, 1, 1, 60, 1 and 2. Okay. This is how we are going to access the elements in a two-dimensional array. For a one-dimensional array, you used to use a single for loop. For two-dimensional array, you're going to use two for loops, one for rows and one for columns. Okay. 2 rows, 3 columns in this particular example. Okay. The example that we have taken here, or the code that is here, so it uses two indexes, that is array row of row and column. Use nested loops. Why do you use nested loops? To traverse or access all the elements, one for row, one for column, and the index starts from 0 for both rows and columns. This was all about one-dimensional array and two-dimensional array. Hope you all understood the topic. Thank you.